Hello everyone, welcome back. So I'm now going to go through an example of how to do a chi-square test for independence on a simple table. Okay, and so I'll go through the steps of the hypotheses and then I'll go back and show you how I got the calculations that I did from Minitab. So here I've got a simple table on gender and handedness. And forgive me, this table is old, so it only has two rows for gender, and we could have encoded more there if we wanted to, but at the time they only encoded two. Okay, so there's the table. Gender and handedness, we've got a 2 by 2 table. So the hypotheses are gender and handedness are independent, null independence, and then alternative, they are dependent. Okay, great. That's the hypotheses. We'll say, for our purposes, that we're going to have the significance level be 0.05. Okay, so it would certainly say somewhere in the description of the table what the significance level is. We'll have alpha equal to 0.05 here. The assumptions, of course, we have our three, both variables categorical. Data is taken randomly, and all expected cell counts are at least 5. Okay, and so the first one is easy. Both are categorical. There are two categories for both. The data is taken randomly. You'll have to sort of go along with my assumption that they are. Great. And then all expected cell counts are at least 5. We haven't seen them yet, so we have to sort of wait and see there. Okay, but it turns out that they will be. And so that third one will be met. We just haven't seen it yet. Okay, so here's the Minitab output. I'll show you how I get the Minitab output right after we're done this example. So here's the Minitab output. Okay, so you'll see on the left, I've got a table-looking thing. Okay, with C1 and C2 are sort of the columns of the table, and then it has row is 1 and 2 as well. So you'll see 40, 15, 40, and 5. Those are my original counts. Those are in the first rows of each of the rows. There, I know it's probably a little weird to look at. Okay, and then they've added up the row and column totals as well. And then below the actual counts, they have the expected counts. And so the expected counts are 44, 11, 36, and 9. Okay, and so we have that all expected cell counts are at least 5, and so we can move on without a worry of something going wrong theoretically. And so that's the left-hand side, and then the right-hand side is where we actually, sorry about that, where everything goes. You have to see all the tabs open on my computer and what I listen to on Spotify. It has the chi-squared test, okay, 2 lines. It has something called Pearson, and then it has another thing called likelihood ratio. We will always look at Pearson. Okay, but there is something else called likelihood ratio, which does a similar test, but it is slightly different. Okay, and so from this we get our test statistic T. Okay, it's going to call it chi-squared. And then we also get the p-value. So we get the test statistic and p-value. The p-value is 0.044. Okay. And so that is less than the significance level. Since the p-value is less than the significance level, we reject the null hypothesis of independence. And so that gives us a conclusion at the 5% significance level. There is enough evidence to conclude that there is an association between gender and handedness. Okay? Now, some miscellaneous things that I want to talk about just for a minute, and then I will go to Minitab and show you how I did the calculation. So there are a number of misuses of that chi-squared test that we do, and so it's defined in this table here, okay? And so some examples are when those expected frequencies are too small, things can go wrong, okay? When the data is not random, great. When separate rows or columns are dependent samples, okay? That's, of course, we're assuming everything is independent along the rows or the columns, and so that's a sort of a weird issue there. And then a fourth is to data by classifying quantitative values into categories. So sometimes we might have continuous or discrete things that we bin to be in different categories. And so when we do that, there's a loss of information there because we're taking away how specific those measurements are. And so it's oftentimes not a great idea to do that, but people do it all the time, and it has some consequences. Okay. Then the last thing I want to say is that there are a lot of other uses of the chi-square test, not just for independence. So there's also things called goodness of fit, which can test if your data seem to come from a normal distribution or some other type of distribution. So we can do lots of different things with this chi-squared testing framework that we talked about. Okay, so now I want to go to, okay, so hopefully we can all see Minitab here, and I want to show you how to do the chi-square testing stuff. So in Minitab, I haven't really said what these variables are called, so on and so forth. I just literally put in the numbers in a 2x2 format. So I have 40, 15, 40, and 5, okay? And so the important things that you want to do are go to stat, okay? And then you may, because of what we've done all the rest of the times, go to basic statistics, and you'll see that there are no options for a chi-square test for anything. There's some goodness of fit test for Poisson stuff in the bottom. That's not it. You need to go not in basic statistics, but down to tables. Because we're dealing with tables, we need to look at the tables. And so what we are going to look at is the chi-square test for association. Because that's what we're doing, association, not goodness of fit, which is down here or somewhere else. Okay, so chi-square test for association. We have the data summarized in a two-way table. Okay, and so it's asking for columns that contain the table, and that is C1 and C2. And so I'm going to select those, and then it asks for labels of the table. And now I didn't make any labels for the table, and so I'm not going to put anything in there, but if you do, you can, okay? And then next, we're going to look at the statistics that we want to be output when I finally click OK, okay? And so what do we want? In the end, when we get our output, we definitely want the test, okay? And we want them to display counts in each cell and in the marginal counts. That doesn't really do anything for us, but we'll keep it there. And then also make sure that the expected cell counts are clicked so that you can check the assumptions. But all of the other things we really don't need. And so when you click OK, it gives you what we saw before, these rows, and then down here the chi-square test. Okay, so that is how you do Pearson's chi-square test for independence. in Minitab. I'll see you next time.